Hello and welcome students once again. In the last class we discussed about atomic number, mass number and electronic configuration. Today we will discuss about how ions are formed, what is valency, what are valence electrons, and we will discuss all of this with the help of some exercises. We discussed about the atomic number, mass number and electronic configuration, right? And this I have shown you some atomic structures, some structures of the atoms which you have seen earlier also in class 8, and here it is again, the complete table in page number 61. I have shown you some of these in the last class. Today we will do some exercise. Today we will actually do some questions from exercise 4b, which is in page number 63. Okay, so we are doing some questions from exercise 4b, and remaining questions you can try yourself and let me know if there is any problem. So let us begin today with this question. Okay, so here you see there is a table. First column is element, then symbol, then number of protons, number of neutrons, number of electrons. Okay, so now if you are to do this, so the first element here is sodium. First element here is sodium, and the next element I have chosen is chlorine. Okay, chlorine. The thing is, now what we have to do is we have to fill up this table. Sodium and chlorine are the elements given here, and we will fill up this table with whatever information they are asking from us. So first thing that they are asking from us is symbol. Now the sodium, the symbol is Na, right? You know all this. And chlorine is what? Cl. This you have known since the starting, right? Since the class 6-7 days. But today here we will also fill up, we will also add the number of protons, neutrons and electrons. For doing that we must know, for doing the writing the number of protons, neutrons and electrons, we must know the atomic number and the mass number, right? So if you remember, we have discussed sodium in the last class also. The atomic number you should know already by now. It is what? 11. Is it not? 11. And what is the mass number? 23. Right? 23. Now, number of protons. Number of protons is how much? Number of protons is always equal to how much? Number of protons is always equal to the atomic number, right? The other way around is also true. Atomic number is always equal to number of protons, right? So, do we know the atomic number of sodium? Yes, we do. What is that? 11. So number of protons will also be 11, right? So we'll fill up this one with 11. Now, number of neutrons. How to find out number of neutrons? To find out number of neutrons, we need to remember what we learned in the last class. We know that mass number is equal to number of protons plus number of neutrons, right? Number of protons plus number of neutrons, that is what? Mass number. Now, if we know number of protons, which we do know here, is it not? We know that sodium has atomic number how much? 11. So number of proton is how much? 11. Since we know that number of proton is 11, we can find out easily number of neutrons, because we also know that the mass number is how much? 23. It's written right here. Now the mass number and atomic number of the first 20 elements you should learn. Okay? It is given in your book. We have discussed in the last class also. You should learn. What should you learn? The mass number and the atomic number, both of the first 20 elements you learn entry. Okay. Now, as we know that the mass number is how much? 23, and the number of proton is how much? 11. We can use the formula that I have discussed in the last class also for this purpose. Number of neutrons equal to, we can simply minus the what? Mass number minus atomic number, is it not? Mass number minus atomic number. This way also we can find out, because atomic number and number of proton is same, so we can use either to find out. So it is what? 23 minus how much? 11. The mass number and the atomic number, right? And what will we get? We get 12, right? So our number of neutrons is how much? Number of neutrons? 12. Okay, clear enough? We can find out number of neutrons how? By subtracting the mass number and the atomic number. Well, we can also write mass number minus proton, number of protons, because number of protons and atomic number is always the same. So we can just, if I replace this with number of protons, it makes no difference. If I replace this with number of protons, it makes no difference. So we will always get this number, that is subtracting these two, we got 12 here. And then last we have got left is number of electrons. Now again, we have discussed in the previous class that an atom is neutral. Do you remember? In the previous class we had discussed that the atom is neutral because in an atom the number of protons and the number of electrons are always the same. Proton carries positive charge, unit positive charge, and electron carries unit negative charge. We had seen the absolute values also in coulomb, if you remember. Is it not? 1.6 into 10 to the power minus 19 coulomb, which is positive in case of proton and the same value but negative in case of electrons. And we can take it as, in the electronic units, we can take it as +1 charge and -1 charge, right? So since we know that the atom as a whole is neutral, there is no charge. That means the number of positive proton and the number of negative electron is always the same. Okay? We have discussed this in earlier last class also. So what we have seen that atomic number is equal to the number of protons, but it is also equal to the number of what? It is also equal to the number of electrons. How do we know this? Because we know the atom is neutral. If it is proton, is whatever the number it is, the same number will be the electron, because charge is exactly the same. Now here we already know proton is how much? 11. So electron will also be 11. Atomic number is 11. That means proton is 11, electron is also 11. Number of electron is also 11. So let's write it down, 11. So the next one here, another example that I have chosen here is chlorine. We will do this in a similar manner. How? See, chlorine, again you need to know the atomic number and the mass number. Okay? Symbol, it is Cl. I hope there is no problem with that. Everybody should know the symbol of chlorine. That is very simple, right? Cl. And atomic number and mass number you should memorize. Now, the thing is that we will talk about this later. But chlorine, as I had given in the last class, remember, the mass number, or we had written the atomic mass of chlorine is 35.5. Okay, but why this 0.5? There was a question. The chlorine is a bit different one. There is a concept of isotopes here, okay, isotopes, which we are going to talk about later in this class, but we can talk about it right now also bit, because we have to. Because chlorine, if I am writing the mass number and the atomic number, we always write atomic mass is 35.5, right? However, mass number cannot be in points. Mass number cannot be in points. Why it cannot be in points? Because when we are writing mass number, what is the formula that I have told you so far? Mass number, we have told you that it is proton plus neutron. Number of proton plus neutron, is it not? So if I say number of proton plus neutron, how can it be in point? It cannot be in point. It cannot be in point. Why? Because see, either proton or neutron have to be in point. Otherwise, how will the point come here? It is not possible. We cannot have half proton. So we cannot take the mass number as point in points, but the atomic mass is in point. What is the difference between atomic mass and mass number? We have to discuss this a little bit, is it not? Well, there is a concept of isotope here. Isotopes. That means chlorine, the atom of chlorine does not exist in the same way, in just the same as it is in every atom. Every atom of chlorine is not exactly identical. That means what? You have learned already in class 8, if you remember, Dalton's atomic theory, which is a little bit here also, where Dalton used to say that all atoms of an element are identical, are exactly the same. Means every atom of chlorine will be the same. However, this was found to be not true. This was found to be not true. We have found that experimentally, scientists have found that then atoms of the same element can be different. Can be different. How can they be different? Well, they found that chlorine atoms, they found two different types of chlorine atoms. Both of them have exactly the same number of protons. And so they have exactly the same number of electrons also, that is 70. Atomic number remains the same. However, what they found is the mass number is not the same. The mass number is not the same. They found one is 35, the other is 37. Okay, this was the difference that they found. So they call these two as isotopes. Isotopes. What does isotopes mean? They are the elements, atoms of the same element. Atoms of the same element having same atomic number but different mass number. Different mass number. Okay? So this is the concept of isotopes, which we will recall again in a little bit later. But what we have understood is that experimentally it's been found that chlorine, although it is the same element, both are chlorine atoms, but they have different mass numbers. One is having 35, the other is having 37. Okay? And the thing is, why is there such a difference in the mass number? Obviously the proton is same and electron is also same. The difference lies in the number of neutrons. The difference lies in the number of neutrons. If you try to find out here number of neutrons for this one, say this 35, mass number 35. So we will do as we have done before. Number of neutrons will be, we can say that atomic number, mass number minus atomic number, like this. So we will get 35 minus 17. How much can we get? 18. Okay? Now the thing is, this number of neutron will not be same there. That we can obviously see that. We can obviously see that if I replace the 35 with 37, we'll not get the same number. Let's do that. Get 20. So the difference actually lies in the number of neutrons. Because of the difference in the number of neutrons, we have different types of atoms of the same element. Basically they are the same element, but the difference is only in the number of neutrons, and hence the difference is shown in the mass number. So if you are doing a table like this, we have to choose either one actually. But the problem is we cannot we can do it for both. If there is one column like this for chlorine, they will either mention the isotope chlorine 35. If they do not mention, we have to think about the natural abundance. Natural abundance, what does that mean? In nature, both these atoms are not found in same amount. So basically this 35, this having 35 mass is found 75% in nature. What does that mean? That means if I take suppose 100 molecules, sorry, 100 atoms of chlorine, okay, 100 atoms of chlorine, what will happen? Out of those 100 atoms, 75 of the atoms will be like this type and 25 of the atoms will be like this type. So naturally this is found more common in nature. Okay, if I can get 100 sample of 100 atoms, we'll always find this one to be 75% and this one to be 25%. So let us assume for this completing the table, the mass number is 35 and the atomic number is 70. But sir, you told in the last class, you might think 35.5 is the atomic mass. What is the problem there? We are coming to that. Let us fill up this table first and then we will go to the concept of isotopes in details. So if I take 35 to be the mass number and 17 to be the atomic number, now what? Now it is as simple as it was before, is it not? So what will happen? Atomic number is 17, that means proton is also what? 17, and number of electrons also always same, so it is 70. And if we subtract these two, which two? 35 and 17, which we showed just now, we are getting 18. So this will be the completion of the table is done. Now to understand that different concept is there, why it became 35.5, the atomic mass, which I mentioned in the last class. Wait for it, we'll get to that in a bit. Let's complete the other problem also. So here we can see the second problem that we have chosen here is orbital diagram of calcium ion, Ca2 plus ion. Now calcium atom you can do, is it not? Calcium atom you can do. In the previous class we have discussed potassium, not calcium, is it not? Let's discuss the calcium ion. First of all, we need to think about the calcium atom. So if you remember the atomic number and mass number of calcium, what was it? We told Bolan the first 20 and calcium is the last one in the first 20, right? And the mass number is 40, right? So if we have to draw the orbital diagram, the atomic orbit structure which we discussed in the last class, we do not require the mass number here, right? Because mass number we require it for what? We require it for finding out number of neutrons basically. So yes, we also need that because it is asked fundamental particles following this. Fundamental particle means subatomic particles only. Protons, neutrons and electrons, which these three only we need. So fundamental particles we need, so we still need the mass number. Right? So let us find out this part only first. So how many protons here? Obviously you can tell by now. So many times I have repeated that atomic number and number of proton is always the same. So proton will be 20. Okay? Proton will be 20. Next, let's talk about the number of electrons. That is also how much? 20. Is it not? Because both of them are the same. Always the same. In a neutral atom. Atom is neutral, remember. But now, the next thing comes is the mass number is 40. So if you want to find out number of neutrons, you have to subtract 40 minus 20. That also comes to be 20. So we know the fundamental particles. But to draw we need to know the electronic configuration. Is it not? Electronic configuration. Let's do this. Electronic configuration. Okay, so in electronic configuration what we need to think about is first of all the electrons. Don't ever, now here both are same, neutron and electron, but I have seen many times people just take the neutron and do it. No, I have done neutron the last, doesn't mean that I'll see this one. It is electronic configuration, I will go for the number of electrons. Okay, here both are same, but it will not always be the same. is it not? So, if you remember the rules that we have discussed in the previous class, first shell can have maximum of how many? 2. So let us give 2. Then we got how many? 20 still. The second shell can have maximum how much? 8. Is it not? But the next one can have how much? The third shell. If you remember, it is 18. Is it not? But how many are left here? You may think. How many are left here? 10 gone, 10 more left. Maximum is 18. Can I give here 10? I cannot give here 10. Remember in the last class I discussed that the last shell cannot have more than 8. The last shell cannot have more than 8. Remember, 8 in the last shell means an octet. So last shell cannot have more than 8. That was the rule. The second rule of electronic configuration. First was the 2n square rule, which is telling us the maximum number that we can put. But if it is exceeding the last shell, if it is exceeding 8, we cannot put. Although if I put here 10, if I add up, it is coming same 20. But I cannot do that because last shell will be 10, which is not possible, which we cannot exceed 8. Okay, so we will give here 8. And how many more left? 2. So last shell will have 2. Okay, this is for whom? This is for the calcium atom. But we are talking about here the calcium ion. So if you move to the calcium ion, there are some things that you need to know before we can talk about the calcium ion. Okay, now atom is understood, electronic configuration is understood. Till this much, it is only a revision of what we have already discussed in the previous class. We have discussed this in the last class, right? Now, if we are doing the atomic, the number of electrons in the calcium ion will be bit different. Okay, so if we know that this electronic configuration, we can do the structure of the atom, the orbital structure. Is it not? The orbital structure. So if I draw orbital structure, what will happen? This one you can draw from previous knowledge also. Proton is how much? 20. Neutron is how much? 20. First shell 2. Second shell 8. Then how much? More 8. And last one 2. This will be the structure of calcium atom, not the calcium ion. In order to understand the calcium ion, how we will draw the calcium ion, first of all we need to know what are ions. Now what are ions is not new to you, is it not? We have discussed ions earlier in class 8 also, but let me give you a revision that last class, in the last part, we had discussed about stable electronic configuration, right? We discussed about helium and argon and neon also. These three are the noble gases amongst your first 20 elements. What do I mean by that? We had discussed in last class that they have electrons max to the maximum capacity of their last shell. Okay, if I am discussing this a little bit once more, so that you may recall this. See, if I have helium, which is having atomic number how much? Only 2. Now I am not discussing about the mass number because I want to show you only the electronic configuration. That part we are interested in. So if I am showing it, first shell has maximum capacity how much? 2 only. And how many electrons here? 2. So it is a duplet. Duplet, in the last class we discussed. It is a duplet because the first shell is the last shell itself and it is filled to the maximum capacity. That is 2. Completely filled outermost shell. It's a stable electronic configuration which we discussed in the last class. Similarly, if I draw neon here, 10. Is it not? Neon is 10. So if you follow the rule of electronic configuration, first shell 2, next shell is how much? 2 gone, how many more left? 8 more left. And 8 is the maximum capacity also. So wait. So we got 8. So here also completely filled outermost shell, stable electronic configuration. And let's talk about the last one here, carbon among the first 20, 18. So you got first shell 2 as usual. Second shell how many? 8. Because if you think about it, 2 and 8, how much it become? 10. So the last shell will have how many? 10 gone out of 18. 8 more. Okay, 8 more. So this 8 here, that means what? We cannot give more than 8 in the last shell. We have discussed already. This is also completely filled outermost shell, stable electronic configuration. These three things are having, all of these three elements are having stable electronic configuration. We can call them noble gases. We can call them noble gases and inert gases. Why so? Because since they have stable electronic configuration, they will not lose, nor they will gain electrons. Everybody wants to be like them. They don't want to be like anybody. Everybody wants to be like them. They don't want to be like anybody. They are stable. Right? They are stable. They don't want to be like anybody. They don't want to lose. They don't want to gain. However, our calcium is not like that. If you remember the structure of calcium that we draw just now, if you remember the structure of calcium that we draw just now, we must remember that calcium had how many in the last shell? Calcium had total 20. So first shell 2, second shell it was 8, and third shell was again 8. I'm just redrawing the calcium one again. And the last shell it was 2. So if we think which is the nearest noble gas to calcium, the nearest noble gas was argon at 18. It was what? Argon at 18, right? And every element, remember this from now on, very important line, every element wants to be stable, wants to have a stable electronic configuration like its nearest noble gas. Okay, every atom wants to be stable, every atom wants to have stable electronic configuration like its nearest noble gas. So the nearest noble gas to calcium is argon, and as we had discussed a little bit ago, the structure of argon has 8 in the last shell, which we also known as octet. Okay, so in order to be an octet, it needs to do what? It needs to lose 2 electrons. To be 8 like argon, it needs to lose 2 electrons. So if I remove these 2 electrons, and if I remove the last shell totally, because no electrons, no need of the shell also, shells are imaginary, remember? Shells are imaginary path in which the electrons are moving. So we got 8 in the last shell. Okay, but now as calcium has lost electrons, we can no longer call it an atom. It is no longer an atom. It has become what? It has become an ion. That's why we are coming back to our question. Calcium ion. It is no longer an atom, it is an ion. Ion is something which is formed by either losing or gaining electron. Okay, losing or gaining electron by an atom. Why do they lose or gain? In order to have a stable electronic configuration like their nearest noble gas, in order to have an octet or a duplet. Okay, in that manner they will lose or gain. We'll see more examples. Let's start with this one first. So since it has lost 2 electrons, now electrons have what charge? Electrons have negative charge, is it not? Since they have lost Before what I told you, that in an atom what happens? Number of proton and electron is always same, is it not? Number of proton and electron is always same. So before it, how many proton was there? 20 proton. And how many electron was there? 20 electron, right? And I told that because 20 electrons and 20 protons, 20 protons have how much charge? All of them have plus 1 charge, plus 20. And electrons have how many charge? They have minus 1 charge, no? So minus 20. Before it was, total charge was 0. Because plus 20 minus 20 cancel. But now you see, 2 electrons are lost. Is it not? 2 electrons lost. Why lost? Because they want to be stable. They want to have a stable electronic configuration. 2 electrons lost. Now how many they have? Here 2 gone from 20, how many left? 18, right? So proton does not change. Proton does not change. Why? Proton is where? In the nucleus, it is going nowhere. It is staying there only, na? It is going nowhere. So proton is still 20, but electron has become 18. Now if I do minus 20 and 18, minus 18 plus 20. So obviously the plus part is more. It will come down to be 2, right? And we can say it is plus 2. Because proton here is more. 2 proton is more than the electron. So overall, when it loses electron, on losing electron, it acquires a plus charge. In this case, it has lost how many? 2 electrons, so it has become plus 2. Now this we have to show in the diagram also. We give a square bracket, third bracket, and we write plus 2 on the top. This is the structure, orbital structure of calcium. Okay? Calcium ion, not calcium atom but calcium ion. And in the calcium ion, fundamental particles, what are the fundamental particles? Protons, electrons and neutrons. Now proton, neutron did not change. Proton, neutron did not change. They remain in the nucleus. So proton was before how much? See, atomic number will also not change, mass number will also not change. Because they don't depend on electron. Okay? Yes, in neutral atom, electron and proton is always same. But when it becomes ion, proton and electron no longer are the same. Proton is still 20, electron is, first let us talk about neutron. Neutron is 20, but electron is less now. Because 2 lost, it will become how much? 18, right? So the fundamental particles, as they are asking, 20, 20 and 18, not 20. If it was atom, all 3 was same, we showed just now. But in the ion, it is not the same. In the ion, it is not the same. Let us see some other examples. Then we'll become clear about losing electrons and becoming ions, okay? We saw that calcium lost 2 electrons, right? Calcium lost 2 electrons. Why did it lose 2 electrons? In order to attain stable electronic configuration like the nearest noble gases, right? And we have discussed already the 3 noble gases that we have in the first 20. That is our helium having only 2. If I am writing electronic configuration as EC, only 2, right? Neon is having 2,8 because they have total how much atomic number? 10. And argon is having how much? Atomic number is 18. So electronic configuration is how much? 2,8,8. Okay? So everybody wants to be like them. Whoever is the nearest to them wants to be like them. So let's see. Lithium. Lithium, right? It is very close to helium. As you can see, it is 3. Okay? So if I do the electronic configuration, it will be 2,1. Now if it wants to be like helium, what will it do? Just like calcium lost 2, it will also lose, because losing it will make same. So if lithium loses, how many will it lose to become like this? Only 1. So it will be plus 1. Right? That many electrons it loses, it is the valency will be equal to the number of electrons lost or gained. There's a concept called valency. The concept called valency. What is this concept of valency? Valency is basically the number of electrons which they lose, an atom will lose or gain in order to, or even share. Another word is share. Lose, gain or share in order to become like their nearest noble gas. Now we had discussed in the last class that the last shell is also known as valence shell, is it not? Outermost shell is also known as valence shell. Electrons present in the outermost shell are called valence electrons. Okay, they are called valence electrons, and the number of electrons lost or gained will be lost, gain or share also we can say will be known as valency. Okay, they are not the same things. I often see students will confuse between valency and valence electrons. Let me just make it clear with some examples here. See, neon is 2,8, and we can think of other elements which are close to neon. For example, we can think of fluorine and sodium. Okay, fluorine and sodium. Fluorine is having how much atomic number? 9. Sodium is having 11. If I don't draw, just do the electronic configuration, you must understand by now that first shell will have 2, first shell will have 2, then next shell how many more left? 7, 2,7. And if I do the electronic configuration of sodium, 11, so 2, 8, 1, because we cannot give more than 8 in the second shell and total has to be 11, right? So they are very close to neon, which is 10, 9 and 11, right? Very close. But you see here, fluorine is having 1 less than neon. Fluorine is having 1 less than neon, is it not? Fluorine is having 1 less than neon, so what will it do? Previously we saw the example of losing, but here in order to become stable like neon, in order to have an octet like neon, it will gain. It will gain. Okay. Lithium had lost earlier, you can see, and after losing it had only 2 electrons left. Now fluorine will rather gain. Fluorine will rather gain, and when it gains, electronic configuration will change to 2, 8. It one more increased. Since electron increased, the negative electron, remember, is negative. Since electron increased, and how many electron increased? Only 1. There will be a -1, or simply we can write minus. Okay, electron increased, so it became -1, and now it is stable 2, 8, just like neon. But if sodium wants to be like neon, stable, how will it do? It cannot gain. It is just like the case earlier we saw with lithium, or earlier that we saw with calcium. It will have to lose, is it not? It will lose, become like neon. Let's see. So if sodium loses an electron, so it will become how much? 2, 8, just like neon. But since it has lost an electron loss means plus, so +1. Okay, 1 plus. That is the valency of sodium. Okay, this thing that we are talking about, the charge on the top, it can be called the valency also, because it is equal to the number of electrons lost. In this case it is equal to the number of electron gained. Okay, lost, gained. We'll come to the case when it is shared also, but it is equal to the lost number of electrons, gained number of electrons. Okay, but it is not the same thing as valence electron. It is not the same thing as valence electron. Why it is not same? Because you can see how many electrons are there in the last shell of fluorine? 7. Is it not? 9 atomic number, 2, 7. So last shell, how many are there? 7. That means valence electrons. Last shell is known as the valence shell. And valence electrons, how many here? How many electrons in the last shell? 7. Okay, 7. As you can see, 7. But how many did it gain? Only 1, is it not? So valency is the -1 here, which is gained. How much it gained? That valency. Since it is gaining, that's why we give the minus sign. But valence electron is 7. They are not the same thing. Here both are same. You see, how many last electrons? Last shell electrons, valence electrons, 1, right? So valence electron is 1. But how many did it lose or gain? It lost 1. Valency also 1, +1. But does not mean that always it will be same. In this case, you can see valency and valence electron is not matching. It can be like that also. Always it will match. It is not the case. Okay, they are two different things. Valence electron means electrons in the outermost shell. Okay, and valency means electrons lost, gained or shared in some cases. Why? In order to attain stable electronic configuration like the nearest noble gas. Coming back to the calcium that we discussed. Here, calcium. Calcium, we discussed the calcium ion, Ca2 plus ion. Why 2 plus? Because it lost 2, right? Calcium was how much? 20, right? Atomic number was 20, electronic configuration was 2, 8, 8, 2. After losing it became Ca2 plus. Electronic configuration is how much? 2, 8, 8, which we saw just now in details. It is just like argon. Since it lost 2, it became what? Ca2 plus. But something like say chlorine is having 17. Okay? Chlorine is having 17. We can take another example also. Sulfur. So first let's show chlorine. So what happens? Chlorine is having electronic configuration 2, 8, 7. Because total 17, first shell can get only 2, second shell gets 8, 10 gone, 7 more, 2, 8, 7. Now to become like argon, it will gain. It will gain and become Cl1 minus. Okay? Electronic configuration is 2, 8, 8. Okay? 1 gain, that's why minus 1. It will not always be 1 gain. Say if I take the example of sulfur, which is 16 atomic number, so electron configuration will be 2, 8, 6. Now how many needed to become like argon? You can see last shell 6, argon last shell 8. 2 more needed, 2 more. So it will gain 2. So it will become S2 minus, and the new electronic configuration will be 2, 8, 8. Why minus 2? Because it is gaining. Remember, gaining is minus, losing electron is plus. And number of electron lost or gained, we are calling it what? Valency. Okay? Very important concept that we discussed today. Valency. Okay?